The desire for invisibility is ancient. It is a concept that has fascinated humanity for millennia, capturing the imaginations of people across different cultures and eras. It stretches back through our history, embedded in the very fabric of our storytelling traditions. From the earliest cave paintings to the grand epics of ancient civilizations, the idea of becoming unseen has always held a certain allure. It is woven into our myths and legends, a recurring theme that speaks to a deep-seated human desire. Whether it's the ability to move unseen through the forest or to vanish from the sight of enemies, invisibility has been a powerful symbol in our collective consciousness. From Greek gods donning the helm of Hades to Harry Potter's enchanted cloak, the allure of disappearing from sight has captivated our imaginations for centuries. These stories, passed down through generations, reflect our fascination with the unseen and the unknown. The allure of disappearing from sight has captivated our imaginations for centuries. It's not just about the thrill of being invisible, it's about the power and freedom that such an ability would grant. Imagine moving through the world unnoticed, observing without being observed. These tales, while fantastical, speak to a fundamental human desire, the wish to control what others see, to vanish at will, to become unseen observers of the world. This desire is not just about escaping danger or playing tricks, it's about the deeper yearning for autonomy and control over our own visibility. For generations, invisibility remained firmly in the realm of fiction. It was a concept that belonged to the world of fairy tales and whispered stories, a magical ability that seemed forever out of reach. It was a concept relegated to fairy tales and whispered stories. Around campfires and in the pages of old books, invisibility was a dream, a tantalizing possibility that sparked the imagination but seemed impossible to achieve. However, the human drive to turn fantasy into reality is a powerful force. Throughout history, what was once deemed impossible has often been brought into the realm of possibility through sheer determination and innovation. With the advent of modern science, the quest for invisibility shifted from the pages of mythology to the laboratories of physicists and engineers. The scientific community began to explore the principles that could make invisibility a reality. What was once considered mere magic is now the subject of serious scientific inquiry. Researchers are delving into the properties of light and matter, seeking ways to bend and manipulate them to achieve the effect of invisibility. The pursuit of invisibility is no longer a pursuit of sorcerers and magicians. It has become a legitimate field of scientific study, with researchers around the world working tirelessly to unlock the secrets of light and perception. Scientists are exploring the very fabric of light and matter. They are investigating how light interacts with different materials and how it can be controlled to create the illusion of invisibility. They seek to unravel the secrets of perception and illusion. By understanding how our eyes and brains perceive the world, scientists hope to develop technologies that can render objects invisible to the human eye. Could we one day manipulate light itself to render objects truly invisible? The answer, as we are discovering, lies in pushing the boundaries of what is scientifically possible. It requires a deep understanding of physics and a willingness to explore the unknown. The answer, as we are discovering, lies in pushing the boundaries of what is scientifically possible. Researchers are developing new materials and technologies that could one day make invisibility a reality. The dream of invisibility is slowly being pulled from the clutches of myth and drawn closer to the realm of scientific possibility. As we continue to explore and innovate, we move ever closer to turning this ancient dream into a modern reality. Nature provides compelling examples of creatures that have evolved remarkable camouflage abilities, effectively achieving a form of natural invisibility. This fascinating phenomenon is not just a simple trick, but a complex interplay of biology, behavior, and environment. Consider the octopus, a master of disguise that can change the color and texture of its skin in the blink of an eye to blend seamlessly with its surroundings. This remarkable feat is achieved through specialized pigment-containing cells called chromatophores, controlled by a complex network of muscles and nerves that allow the octopus to mimic the colors and patterns of its environment with astonishing accuracy. The octopus's ability to camouflage is not just about hiding from predators, it also uses this skill to sneak up on prey, making it an effective hunter. The rapid changes in its appearance can confuse both predators and prey, giving the octopus a significant advantage in the wild. Then there is the chameleon, another creature renowned for its camouflage prowess. While often mistakenly thought to change color to match any background, chameleons primarily use their color-changing abilities for communication and temperature regulation. However, their ability to shift between shades of green, brown, and gray allows them to blend remarkably well with foliage, providing a degree of camouflage that helps them avoid predators and ambush prey. The chameleon's color change is controlled by layers of specialized cells under its skin. These cells contain different pigments and can expand or contract to produce a variety of colors. This process is influenced by the chameleon's mood, temperature, and light conditions, making it a dynamic and versatile form of camouflage. These examples from nature highlight the power of camouflage as a survival strategy, but the natural world is full of other creatures that have developed their own unique ways to blend in. From insects that look like leaves to fish that resemble the ocean floor, camouflage is a widespread and essential adaptation. Scientists are fascinated by these natural camouflage strategies and are studying them to develop new technologies. By understanding how animals achieve such effective camouflage, researchers can create materials and devices that mimic these natural abilities. For example, researchers are developing fabrics that can change color and pattern, much like an octopus or chameleon. These materials could be used in military uniforms, making soldiers less visible to the enemy. They could also have applications in fashion, allowing people to change the appearance of their clothing with the push of a button. By studying the mechanisms behind natural camouflage, researchers gain valuable insights into the principles of light manipulation and visual perception. This knowledge can then be applied to the development of new materials and technologies designed to render objects less visible, if not completely invisible, to the human eye. The potential applications of artificial camouflage are vast. Beyond military and fashion uses, these technologies could be used in architecture to create buildings that blend into their surroundings, reducing visual pollution. They could also be used in transportation, making vehicles less visible and reducing the risk of accidents. The natural world with its array of camouflage strategies serves as a living laboratory for understanding and replicating the art of invisibility. As we continue to study and learn from these masters of disguise, we unlock new possibilities for innovation and creativity in our own world. The journey of understanding and replicating natural camouflage is ongoing, and each discovery brings us closer to mastering the art of invisibility. The wonders of nature continue to inspire and challenge us, pushing the boundaries of what we can achieve. Invisibility, at its core, is not just about making an object disappear, but about manipulating light in a way that deceives the observer. This concept has fascinated humans for centuries, from ancient myths of cloaks of invisibility to modern-day science fiction. But how does one actually go about tricking the eye? The answer lies in understanding the fundamental principles of light and vision. To understand this, we must first understand how we see. Our eyes are complex organs that detect light and convert it into electrical signals, which are then processed by our brains to form images. This process is so seamless that we often take it for granted, but it is the cornerstone of how we perceive the world around us. Our eyes perceive the world around us by detecting light that is reflected off objects. This reflected light carries information about the object's shape, color, and texture, allowing our brains to construct an image of what we are seeing. The quality and direction of this light can significantly affect how we perceive an object. This reflected light carries information about the object's shape, color, and texture, allowing our brains to construct an image of what we are seeing. For instance, the vibrant colors of a flower or the intricate texture of tree bark are all perceived through the light that bounces off these surfaces and reaches our eyes. Optical illusions exploit the way our brains process visual information, using patterns, colors, and contrast to create images that appear to defy logic or reality. These illusions can make flat surfaces appear three-dimensional, or static images seem to move, all by playing tricks on our visual perception. For instance, a well-placed mirror can make an object seem to disappear by reflecting the surrounding environment and obscuring the object itself. This technique is often used in art installations and magic tricks to create the illusion of invisibility. Similarly, carefully positioned patterns and colors can create the illusion of depth or movement where none exists, effectively hiding objects in plain sight by confusing our visual perception. This principle is widely used in nature, where animals use camouflage to blend into their surroundings and avoid predators. While optical illusions provide a fascinating glimpse into the malleability of our perception, they are limited in their ability to achieve true invisibility. These illusions rely on specific conditions and can easily be disrupted by changes in the observer's position or lighting. They typically rely on specific viewing angles and lighting conditions, breaking down when the observer moves or the lighting changes. This limitation makes them impractical for applications requiring true invisibility, such as stealth technology or advanced camouflage systems. Nevertheless, understanding how optical illusions exploit the quirks of our visual processing provides valuable insights for scientists and engineers developing invisibility technologies. By studying these illusions, researchers can learn how to manipulate light in more sophisticated ways, bringing us closer to achieving true invisibility. By learning to manipulate light and deceive the eye, we can begin to approach the concept of invisibility from a scientific perspective. This journey from optical illusions to advanced light manipulation technologies is not just about making objects disappear, it's about understanding and harnessing the fundamental principles of light and vision.